my talk is centered around the state of digital archiving in India and with special reference to Kerala, and how to use tech and related infrastructure to generate archival versions of Malayalam content. And also, I will describe briefly, very briefly, in a qualitative fashion about the principles involved and methodologies and the workflow in general. So I will not be going deep into the technical side or the macro part of the workflow or the packages. Coming to the question of archiving in India, as also in Kerala, people are not at all worried about the archival, but digital archiving part of the content. Even the publishers are not worried about it. I mean, I'm talking about the Indian publishers or the local publishers. Except for the international publishers and the people working for the international publishers, nobody is having any idea about what digital archiving means or what the longevity of the document sources or reusability of the sources or future-proof formats of the contents. Even the government and the universities, which in other parts of the world are very much interested into that, but in our place, it's not the case. They're hardly interested in archiving the content that we are having. People generally believe that the ultimate culmination of the content is the print. And it's always centered around creating a print version only. And in most of the languages in India, still the PageMaker, it's an obsolete software, still runs and still goes there. Even I doubt even Unicode is percolated into many parts of India. That's the kind of situation here. And also they store the sources in very obsolete file formats, like PageMaker. The best example is the Hortus Malabaricus. It's a 12-volume Latin treatise on the flora of the Malabar coast. Recently, our university, not recently, 1.5 decade ago, our university published the Malayalam translation of this valuable collection of books. And at that time, they used PageMaker to create the print version, and they printed and released it, and it sold like anything. And after some time, they stored the files in PageMaker format. And after 1.5 decade, they found mistakes and they wanted to release a second edition of the Hortus Malabaricus. And when they tried to open the system which is used to generate the second edition, it failed miserably. And the content could not be properly retrieved and they could not do anything at all. Then somehow they captured the data, then the whole editorial process had to be run afresh. It's a huge task, a human effort. And then they published it. But the sad part of that is, even then, the publisher is hesitant to think about the long-term preservation of the source data in future-proof formats. And after 10 years, this is going to repeat again and again. And also, they totally disregard the longevity or reusability of the data, of the sources. And also there is another problem. Recently we had natural calamities like floods in Kerala, and most of the year is repeating and repeating. In 2018, the flood was very, very disastrous. And we lost very rare collections of books once for all, which we have lost eternally. and there is no digital copy available for those things. Now, around 86,000 manuscripts reside in our manuscript library of the university, and so also an estimated equal number of books, printed books are available, which none of them have got a digital archival format. This is very disastrous, but in other part of the world, things are quite different. Even the dissertations have been digitized and all those things are available. But here it is entirely different. So it is at this situation that we, a few volunteers of the Sayahna Foundation, which is a non-profit, working here in Trivandrum, engaged in open access publishing of publicly available content, decided to create software and showcase the best practices so that others distribute the software and others can make use of it following our model if they think it is good. And as you can imagine, Sayahna Foundation uses check and related infrastructure for its own creation of digital formats in PDF and whatever. So that was the main reason why we chose check as a means of generation of digital formats. Our decades-long experience in check and XML was the main reason. So also the programmability of check and the ability of check to generate different kinds of PDFs for immediate human access, and also XML from the same LaTeX sources. And apart from this, the possibility of automation intertwined with the usage of free software is also one of the biggest reasons to make use of check. It goes well with our ambition to distribute the software, which means there is no vendor locking. We are not locked to any proprietary software. It's completely free and open. So we can freely distribute among the community and they can make use of it. This is also one of the reasons why we use check to generate the XML. And it also brings in the possibility of the community, the user community, to improvise it, to add more features, etc., etc. So these are the main reasons why we chose check. And check is very excellent for creation of high quality printed books. It can create good quality PDFs for printing. But the highly powerful macro language of check creates a lot of hurdles on the way of creating XML from a text source, because both follow different grammar and different structure. That's the main problem with check. But generally people have devised several methods of creation of XML format from LaTeX sources. And some of I will describe 1 or 3 different kinds of this process. Now, the first one is the parsing of the LaTeX sources and emit an XML out of that, which is mainly used by LaTeX-ML and Tralix. In that case, you have to re-implement check that can understand the macros, the functions, various packages, and then properly output the XML elements and attributes at the correct locations, which is a huge task. But still then, it can bring you surprises at times, and you have to, it's an ongoing process because the packages are getting developed every day and revised every day, and it's always a moving target. And the second method is DVI-based stuff, which Tech Forestry kind of software follows. Tech Forestry follows this method follows a different kind of method, where Tech compiler used for as a translator, which means you need to create, just a customization layer over and above what is available already for LaTeX. So you need to inject some sort of the elements and the attributes at appropriate locations in the DVA output as special commands, which means you won't see it on the output, but it will be there. Then you do a post-processing, perform a post-processing with which you can extract the text as well as the embedded XML elements and attributes, which gives you an excellent result. In our experience and at our work, we have been using TEG Forestry at least for some 20 years, and it gives us excellent results so far as any kind of XML or any kind of complex XML, or including MATHM, and you can customize to any level. That's one of the biggest possibilities of this second method. And there is another method where you create a variant markup, which is in XML, which look like or simulate the LaTeX structure. And then you apply XSLT to create a LaTeX output or an XML output, which whatever you want. But this is primarily used by author community. Some of the authors might be technically savvy and they can create such documents and they can publish the PDF as well as an HTML onto the web. So these are some of the methods which I know or we know. And we always chose the second method, DVA-based injection of XML elements and attributes and then extraction from the output, which we are quite familiar and that is easy for us. But however, this cannot be directly applied to our language because when we started the work, say around 12 years ago, 30 years ago, TEG Forestry didn't support complex script or Unicode. Hence, we have to devise some other method to do that, which I will shortly explain. So now the question of XML DTD, the choice of XML DTD. There are several popular DTDs available. We deliberated on JADS, which is very quite common and community supported. Then DocBook, which is popularly used by Linux people for their documentation. And then elsewhere, XML DTD. Although you cannot make changes there, but you can use it. It's as in freeware, you can use it. And then comes text encoding and interchange, that's the TEI, which is used by European Union and most of the humanities people. So at last we chose TEI DTD because most of our work are related to humanities, or literature, or politics, economics, and those kind of things, and fiction. So it's better that we go for TEI DTD. And it caters a wide variety of content types. You can use it for simple article or even technical content because it supports mathematics and MathML. And it supports linguistics, lexicon, grammar, whatnot, and even movie scripts. So the range is huge, and we have such kind of data with us. So TEI might be the best option for us to do the job. And there's a community-supported software infrastructure is also available for TEI DTD. You all know Sebastian Dars, and he was working for the TEI consortium, and he has contributed enormously to the TEI cost. So you can translate to TEI XML from different sources, and also you can translate the XML sources into different kinds of formats also. So software is available, and even if you're amateur, you can make use of it. And it supports the nuances of the humanities, what the humanities scholars demand. like the manuscript description, the manuscript might be a palm leaf one, and you might have got different locations, got different types of different versions of palm leaf manuscripts from different locations of the state or the country, and each might be having a little bit of differences between them, and TEI provides to capture those differences and note it properly. And that's a big advantage of using the TEI. And then critical apparatus, which is something connected with the semantic meaning variations, and if you have over the years or over the century, usage has changed. You can note that originally what was the usage, the meaning of the phrase, and what is the meaning of the phrase at the moment, and you can record all those things. And these are all necessary for the humanities, and so that's why we went for this TEI. And it has got also exhaustive metadata, which most of the, of course, the Elsevier DTD has excellent metadata, but so also JAS, but it will never come nowhere near this TEI. It is quite huge, and you can do a lot of things. That if your metadata is exhaustive, you can do a lot of things there. You can capture a lot of things. And also it has got superb documentation. I thought that tag by tag is the best documentation I have ever read. But this is something of 2,800 pages, huge. The volume doesn't make it better, but it explains a lot of things. And also, Sayahna Foundation wants to publish a digital lexicon. And TEI helps that also, and it's well documented. So these are all the advantages of making use of this TEI DTD. Now, coming to this question, there is a workflow and how we will create that. I told that we cannot directly apply tech forestry for generation of XML DTD, XML from Malayalam documents. So what we did was, instead of creating a DVI, we created a PDF using LaTeX, which supports Malayalam. And the output will simulate or mimic the XML structure. I will just show you an example of that. You can see that. So this is a PDF, this is not a text file, this is a PDF. I created a PDF like that. So from this PDF, we apply PDF to text, a small program, which extracts the text alone from that. And also a small regular expression is also applied, because just to remove the spurious spaces and empty elements. And it generates TEI encoded XML. And this XML is parsed against the DTD, and if it passes the DTD and parsing, HTML is derived from that. If it doesn't pass the parsing, then we again go back to the editor. We edit it, locate the error, fix it, and again repeat the process. That way, it is repeated until we get a fully parsable XML, TEI encoded XML. That's what we do. The same LaTeX source is used for generating PDF for printing, which is a straightforward business, and also a PDF optimized for reading on the phone screen. And the general structure of TEI DTD, we need to have a general idea of what the TEI DTD demands from us. So it has got mainly two elements. That's one is the TEI header, as the name indicates, the metadata, and then the text. These are the main two elements. And the text has got front, body, and back. The name tells you what it holds. And then there is a synodata, which is it's not mandatory, but it's optional, which can hold, it's a container, if any changes in the alphabets used or scripts used, or some of the scripts may not be used these days. For example, in Malayalam, we have these Malayalam numerals. The old books, all the old books are having Malayalam numerals, which none of us are able to read it now. So we need to use Arabic numerals in its place. And here in this Sino data, we can keep what are all the characters and what transformed into some other step, some other character, some other script. And even it can keep a regular expression also. And then revision history, which is nothing, it's the history of the revision, history of the digital document. And if you look into the TEI header, it has got a few important elements also. File description, which says that title statement, and then which has the title, author, and the names of the responsible persons, like who captured the data, who proofread it, who cleaned up, or who encoded it, and those kind of things. And the publication statement, which is nothing but exhaustive bibliographic information about the digital document, digital XML. And then source description, the original source info. And then encoding description, which is the relationship between source and digital text. I mean, if standard spelling is used or modernized spelling is used instead of the old spelling, and you can have what process has been used and what software is used to generate such kind of things, which we can all keep all this information also in the XML. And then profile description, non-bibliographic aspects of them, like the language use or subset of a language used, and the historic context in which the book was written, such kind of things. These are all the general structure of the TEI DTD. And TEI header is very exhaustive, and the ordinary standard LaTeX document doesn't provide that much of information to create the TEI header. So this is a problem for us. So we thought we will have an extra input file which will have all the metadata information by defining definitive LaTeX commands, and we will keep all this information as its arguments. And then we just create a redefinition spree. I mean, the environments are easier because it has got a start, a begin element, and an end element, which is so easy to do. And slowly, I mean, in the next slide, I will explain about, I'll show an example about how a simple macro is defined. And the packages are modularized so that the maintenance is easier. And in the right side, you can see there's a hub, the master package, the TEI style, and then the meta. Then there's a front, there's a body, the figure, table, back, and also hooks. So hooks is, at that time there were no hooks when we started. Then later on, L3 introduced the hooks mechanism, and just a basic hooks thing is there. As I told before, the environments are easier to redefine. So the renewal document environment, for example, the quote is there, and you simply say quote, and the end can have the closing quote. And if there's a par, and par is started again, and whatever is the DTD demands. But the commands that doesn't have a end thing, like section or chapter or part or item or item. And there you need to find the end of the chunk of text, which you know to think about that and write clever macros. The heading in the LaTeX is highlighting that argument so that it catches the attention. It says that this is the heading. But in XML, it's always a chunk of text, a logical chunk of text. So if you look into the right side, the example is there. There's a body, then there's a diff, which is the logical chunk of text in the TEI DTD. And the attribute is, there's a part, and inside the part, there's a chapter, and inside the chapter, you have the section, and then a section closes and another section starts, and that section closes, and the chapter closes, and then part closes, and then body closes. I mean, that logical closure should be there in sequential order, nested order, which is very difficult. I mean, when you are thinking about symbol redefinition of the LaTeX macros. There you have to think about it and do the thing a little bit cleverly. And as I told before, the XML is validated by XML lint, and if it passes the validation, and we create the XML from that by making use of XSLT plus Saxon libraries. And PDF for printing from LaTeX, PDF is generated for printing is also generated, which is nothing but a straightforward thing. And PDF optimized for smartphone screen is from the same LaTeX sources. A special package is written for that to allow variable page length. I make use of Boris's algorithm for that, and that helped us a lot. And each section is a page, because otherwise you will have hundreds of pages in a screen. So each section might be longer or smaller, and if it is longer, the page will be longer. The limit is the limitation imposed by the PDF specification. So that is very popular among our readers. I mean, it is being released most of the days. At least one document or one short story or one poem is released most of the days, and we have released hundreds and hundreds of documents like that, and which is very popular among people because they can easily read over the phone, and without moving this way and that way, is cleanly formatted for the optimized for the screen. So it's generally is good. And the whole process is automated by making use of the makefile and a few targets, and it goes as a breeze in our system, in the GNU Linux system. On the right side, I'm having an example of that, as we see in the web page. It's HTML, a snippet of the HTML, as we see in the web. This is the example of the screen PDF, smartphone PDF. Each column is a page in that. And this is the XML, TEI XML version of that. And this is the metadata, and that's the part of the real data. And now we will come to the limitations of this system. This is a very simple, tricky job. I mean, this is not an exhaustive thing. Although we created something like XML 86,000 pages of Malayalam content by 2-3 volunteers over the years, and the work is still continuing. It doesn't support maths, which is the biggest limitation. But for Malayalam content, not many math books are there, so it's not an immediate requirement, but still it doesn't support. But it imposed a big limitation on us. We have a 16th century book called Yukti Bhasha, which is a treatise on astronomy written in Malayalam. It predates Isaac Newton 2 centuries. And we couldn't archive it. I mean, it has got mathematics like this in Malayalam. It uses Malayalam notation for mathematics. And we couldn't archive it till now, and which we need to do. And thorough rewrite of the hook style is necessary, but now the hook module is exhaustive now in L3, which we should make use of that. And the good point is, Tech Forestry now supports complex scripts. So probably we might rewrite the entire process, throwing out the lower LaTeX pathway, and instead we will use the real DVI based extraction method using Tech Forestry. And also, we have a problem of unwanted ligature formation in certain combination of consonants. Very few, but we need to examine that. For that, we are applying the regular expression just to fix that. And for these things, we solicit support from the user community. So the data with the entire packages, examples, and basic documentation are available here in this URL, and the license is LPPL, and the example site that can be viewed at our main site, books.sayahna.org, where so many other things are also there. The slide is there, not right. Yeah, we're coming to the end of the story. This is the colophon, and I used this presentation by check. I mean, most of the people did the same thing, but still I just kept a colophon. LaTeX is the compiler, and Beaver is the class. I don't know how it is pronounced, Malosh or Moloch? Moloch. Yeah, Moloch. Okay. It's a theme used, written by Johan Garson, and Source Sans Pro is the main font used. Now I'm concluding my talk, and if there are questions, I've tried to answer.
It's not a question or something like that. Just want to understand the purpose of this is an archive material you are going to do. It's not about a newly created material or something like that. If my
No, it's not a newly created step.
Not a newly created, am I right?
Actually, for Malayalam, we newly created it. I mean, you mean the software?
No, I'm talking about the software. You have a copy editing in the process, am I right?
Oh yeah, the Malayalam content, and we are getting from OCR, we are getting from some other sources, we are getting maybe even checkpoints, and then you need a copy editing kind of thing. And of course, I mean, the OCR might inject some unwanted stuff into that, because the books are always old, and it can have impurity. I mean, some sort of things will be there, and it can create junk characters, even Arabic or Japanese, whatnot, and then you need to clean up it and copy edit it, and their own punctuation marks might be different. Those kind of things, yeah.
Because of archive, I thought, why do we need to have that step? That's it.
Okay.
Thank you very much for the presentation. And I deeply appreciate your desire to archive this process of digital archiving to preserve the texts which are there in the Indic languages. What I'm going to say now is not a comment, nor is it a suggestion, but it is just food for thought. We have to think about it and discuss about it. Most of the, as you mentioned about the astronomical text.
Yeah.
Yeah.
Yukti Bhasha.
Huh?
Yukti Bhasha.
Yukti Bhasha.
Yeah.
So there are a lot of such texts in different fields of science in India. Many of them in Sanskrit, some in other languages, etc. So when an author writes a text, he has his own thought process, how he writes or how he presents the text. So instead of relying on a Western methodology to understand the math which is involved in those texts, I would like that we invest time and efforts and energy in doing research to understand the author's way of presenting the text. There are so many examples. Vedic mathematics is there. A lot of astronomical texts are there, like that. This is my humble, neither a suggestion nor a comment, but it is just a food for thought.
Okay.
Thank you. Thank you.
So
I don't know whether there is an initiative in Stanford, Stanford Initiative on Language Inclusion and Conservation in Old and New Media. They are mostly interested in the languages which are threatening extinction, and Malayalam, of course, is very popular, but I never realized that you have problems with preserving literature in Malayalam. I wonder whether you can contact them. They have a lot of interest in such things, a lot of knowledge, and they put a lot of effort. Maybe you would be interested in contacting them.
Yeah, of course. Yeah, will be. Surely.
We'll talk offline about this, and I can give you.
There's another.
So, as I understand it, you have quite an involved workflow that you extract structured information out of the LaTeX source files. And previously, we've heard a talk by Frank and Ulrike about the tagging project, which is when you enable the tagging, the tags and the structure of the document are included directly in the document, and you can extract it as an XML using the show tag PDF tool, which was also mentioned. Wouldn't this be easier for you? Have you considered using tools such as this instead of going through the generating a LaTeX document which includes the XML tags visually, and then scraping the XML from the document, and so on? You also mentioned that there is no support for math in your workflow, and as Frank has shown, the tagging project supports math, so I was just wondering if it wouldn't be both easier and also more feature complete for you. Thank you.
Yeah, that's a possibility. I mean, when we started around, say, 14 years ago, at that time, we didn't we didn't think about such things. I mean, it's only recently we were all discussing about these kind of things, and when we started, and it was an intimate requirement at that time. We have to do, otherwise a lot of books are being destroyed by natural calamities and things like that. So we immediately did something. I mean, that's the thing, and now we can improvise and take into consideration of all the suggestions raised now. I mean, commented out now, like Brajaraja and you. Yeah, we will think about all those things and we'll go forward. Because only 3 persons are working on it and very few volunteers. And still it is volunteer type. And their day jobs are different. they might have a little bit of time. Still we could manage to create some 86,000 of pages, and which I think is still remarkable.
Thank you.
Thank you, Sylvia.
Thank you very much.